Angela, can you tell me a little bit about the roots of the community renewable scheme here?
Well, this goes back to the late 1970s when the whole of Knoydart was owned by Major MacDonald, and up until the late 70s power had been supplied by a village generator just a couple of doors down from this office. But in the late 70s, 78, 79 I think it was, hydroelectric scheme was installed, taking water from Loch Bromisseg down to the turbine house, excellent head of water, so potentially a really good supply of power, and that was distributed to the local village. Then the community got involved. There was a community association, and they purchased, I think, some of the extra distribution system, and they sort of kind of managed that in, presuming, collaboration with the then owner. Unfortunately, in the sort of late 80s, throughout the 90s, we had a series of landowners who at that time, after the estate had been split up in the early 80s, they owned a number of properties, a lot of land and the hydroelectric scheme, but didn't necessarily invest in it, maybe as well as they should have done. So the community buyout took place in '99. One of the first priority projects was to get funding to actually upgrade the scheme.
So can you just clarify, that was the community buyout for the whole estate?
That was for the whole of the Knoydart estate. So that was 17,000 acres of land, the hydroelectric scheme, properties, residential properties, a small number of them, the bunkhouse, a lot of old buildings, lots of old farm buildings, all of which were in very, very poor condition when the community buyout took place. Right. Upgrading the hydroelectric scheme was a priority project. With the help of the Highland Council, a scheme was drawn up that looked at upgrading the dam, upgrading the turbine and upgrading the distribution system. So we had originally the scheme was about £500,000 in cost, but when we got tenders back for the three sort of different areas of works, it wasn't sufficient to upgrade the whole of the distribution system, and we had to make modifications to the scheme. But tenders went out. The main tender for the civil engineering works, which was upgrading the dam and renewing the pipeline, was won by a firm called CCG. They subcontracted the scheme to a small contractor, which was probably just as well because CCG went into liquidation 2 weeks before the scheme was finished. But to give credit to Sandy Thompson, he got the scheme finished, not necessarily to the quality that was really needed, but we actually got the scheme up and running, and having had a year of running on generator, we went back onto running on hydro. So this was 2002. But since then we've had to carry on upgrading the rest of the distribution system. We've had to make good some of the works that were undertaken as part of that refurbishment. And I think what you realise is actually running a sort of refurbished hydroelectric scheme, you've got to keep on top of the maintenance all the time. It's not something that you ever finish, it's an ongoing job. But we've got a good team who do maintenance, we've got contact with a good electrician, good high voltage engineer. So we do have a regular investment programme on a year-by-year basis, and you know, we run the scheme ourselves, everything from maintaining it to doing the bills to doing all the monitoring side as well.
Jim was telling me that there are plans to sort of try and get the full capacity out of the system. It's around about 180 at the moment, but it could be up to 300.
Yeah, I mean technically it's all rated at 280 kilowatts. In theory we might be able to get 300, but unfortunately at the moment it's only operating at 180 kilowatts a minute, conks out. Now we've been doing load tests, we've done a lot of investigation into what the problem is. We were hoping it was going to be a nice simple problem, that there was a physical blockage in the pipe somewhere, and once we remove that we'd be back to 280 kilowatts. It doesn't look as though it's going to be quite as simple as that, and what we think is that it's like an incremental problem over the whole length of pipeline, possible sort of small amounts of debris at each joint because the joints weren't put in quite as smoothly as you would hope. But we think we've pinpointed a couple of areas where hopefully we can make a difference. Whether or not it will get us up to 280 kilowatts we won't know. It's more likely it might get us up to 240, 250 kilowatts. So we've got works that we need to do up at the head of a dam, where the water actually comes out from the dam into the start of a pipeline there. So we've got plans to upgrade the pipeline there. We'll see what happens then. Once we get that done, we'll do more load tests, see if that makes a difference. And if that doesn't, or only makes a small amount of difference, the other possible area is to renew the pipeline down at the bottom of the slope, where the pipeline comes into the turbine house. No guarantees that they're going to completely solve the problem, but from various engineering reports that we've had done, it looks as though they are the likeliest areas. But neither of those are cheap operations, so we've just got to do it incrementally as and when we can afford to do it, as well as keeping on top of all the other maintenance that we need to do as well.
Okay, and you'll be able to use that extra capacity?
Well, the problem we have is, at the moment, the pipeline provides us on a day-to-day basis with enough power. You notice it at peak times such as New Year's Eve. But if you look at the monitoring that we're doing, when you look at the graphs that show the usage, incrementally we're increasing and using more and more power on a sort of year-by-year basis. But if we know that we can deliver 220, 250, 260 kilowatts, whatever it might be, we can actually have a forward plan for using that. The problem we've got at the moment is that if someone came to us with a business, for example, that used a certain amount of electricity, we might not be able to guarantee them that they could actually have that power on a constant basis. So it actually makes developing a forward strategy for the company very, very difficult, because okay, 180 kilowatts, if we stayed static, actually is fine. We can manage New Year's Eve. That's, you know, we put the village onto generator, we run everybody else on hydro, and generally speaking, that's fine. But we would have to stay static. We wouldn't really be able to develop much more as a company if we're limited to 180 kilowatts. So that's kind of quite a limiting factor for the community as a whole.
Okay. Obviously water is an enormous resource here for energy. Are you looking at any other options, solar, wind?
We have a sort of small number of Foundation properties have solar panels on, so there's sort of certainly individual interest possibly in solar. Wind we haven't considered other than a sort of back of a fag packet. The trouble with wind, to sort of justify it, would probably, well, we actually looked at wind as if we wanted to look at an underground subsea cable to actually connect into the grid. I think hydro is our best source of power, but one of the things that we would like to look at is whether or not there's another water source actually within the village that we could have as an alternative water source. It would be good to be less reliant on just one source of power, but hydro is probably the most effective source here, rather than bringing in wind or solar. But having another source rather than just the lot Bromwich egg would be the best option.
Okay. The egg approach to capacity has been to ration houses and businesses. You've not looked at that?
Well, it would be easier said than done. The good bit that the good position egg were in was that they were starting off from scratch with a brand new system and could start off from day one. But the trouble was, we inherited a system here where people had meters and they were just getting a supply like anywhere else on the mainland. And actually we're in this dilemma where we actually want people to use lots of power, but we want them to use it sensibly and to understand the limitations with the system, because obviously the more people use, that's good income for the renewables company, and it's good from a ROC's point of view. So we've got some houses that have actively been encouraged to use a lot of electricity, because they use electricity as their primary heating source. So if you suddenly restricted it, you would have to look at probably different levels of restriction. You know, the schools on electric heating, private residential properties are on electric heating, foundation rented properties are. So I don't think you could go back to a one-size-fits-all, and then it would actually have quite a significant impact on the power that was used. So it's a bit of a dilemma for the company, is that side of it.